Okay, in this lesson, we're going to use trigonometry to work out angles. All right, should be a recap. So let's see how it goes. First things first, find the size of this angle here, theta. So let's label the sides first. H, O, A. As always, write down SOHCAHTOA. And then, well, I've got the opposite and the hypotenuse. So I'm going to use sine. I don't know what the angle is, but sine theta equals 9 over 18. Okay, remember, because sine is opposite over hypotenuse. All right, now remember the trick is now I need to get just the value of theta. That means you've got to get rid of the sine. To get rid of the sine, you take the inverse sine. Okay, you push shift then sine on the calculator, and that will come up. Put the fraction in, and you're going to get the theta is bang on 30 degrees. Okay, so to find an angle, use the inverse function. Next one, I've got to find the size of angle beta. Okay, it's here. So H, O, A. SOHCAHTOA. I have got H, and I want to find A. Sorry, I got H, and I've got A. Okay, and I want to find the angle. So I've got to use cos. Let me just pause it 2 seconds. I'll come back to you very shortly. Okay. Okay, I'm back. Sorry about that. So as I was saying, we're going to use cos. So cos beta. Remember, cos is A over H. So it tempted on you, okay, to do 60 over 2. That would be wrong, look, see, because this is in meters and this is in centimeters. So I think I'll put this here as centimeters, okay, in the same units, and then do adjacent over hypotenuse. Remember now this time you take the inverse cos, not the inverse sine. And I haven't memorized this one because I'm not that weird. So the inverse cos of 60 over 200 gives you 72.54 degrees. The 2 decimal places. Okay. Last one then, example 3. Find angle delta. I'm rocking the Greek alphabet today. But check that these are both in the same units, so I'm good to go. All right. H, O, A. So got O. So O is 4 points. I got O. I've also got A. So I'm going to use a good old 10. Okay, so tan delta. Tan is opposite over adjacent, so it's 4.6 over 10. And obviously this time round, take the inverse tangent. And see what happens. It's tan minus 1, 4.6 over 10. And you get the delta is 24.7 degrees to 2 dp. Okay. For the main task now, right, I'll post a worksheet alongside this video. So attempt that. Take about maybe 20 minutes, half an hour. Once that's done, come back for the checking question. Okay. Okay, so welcome back. Here's the check. Just going to go back here 2 seconds and insert the slide after it, just so I can have a bit more space to work on. Okay, here I go. Come back to it then. All right. So a ladder is placed against a vertical wall. The ladder is 2.6 meters long, and the gap between the bottom of the ladder and the wall is 80 centimeters. Well, okay, so the first thing I spot here, let me put this in centimeters to avoid a clash of units, all right? That's 260 centimeters. Ladder should be placed at an angle of 75 degrees to ensure a person's safety, although a small error each side can be tolerated. Can the ladder be classified as safe? Show all your workings. Well, I think I will turn all this text into a picture first of all. Okay, so we've got a ladder against the wall. So here's the ladder. Okay, and it's up against the wall, and obviously it's resting on the floor. And so this here would be a right angle there, because this wall is supposed to be straight. All right, just excuse my drawing. So what else do I know? The ladder is 2.6 meters long. Remember that was, so the ladder is 260 centimeters long. And the gap between the bottom of the ladder and the wall is 80 centimeters. So, sorry, this gap here is 80 centimeters. And it's saying the angle should be about 75 degrees to be classified as safe. Okay, so I think I'll have to work out this angle here. I'll call it theta, and I'll see how close it is to 75 degrees. So in this triangle, that's H, that's A, and that's O. So as always, SOHCAHTOA. And I have got H, and I've got A. So I'm going to use cos. So cos theta is A over H. Take the inverse cosine of AD over 260. So shift then cos, and then AD over 260. And you get that theta is 72.08 degrees to 2 dp. And the question did say the ladder should be at 75 degrees. Okay, although a small error each side is tolerated. So can it be classed as safe? Well, opinions might vary here, but I'm going to say this is very close to 75. It's only 3 degrees off. Actually, it's only 2.92 degrees off, which is a very small angle. So I'm going to say, all right, that the ladder is safe because theta is close to 75 degrees. And you might want to even give the difference. Okay, it's actually 2.92 degrees away. Now, equally, if you said the ladder wasn't safe because it's not 75 degrees exactly, if you think 3 degrees is too big, as long as you justify it, okay, then you would get all the marks in the exam as well. But I'm going to say it is pretty much safe because it's very close to 75 degrees. So I'll leave it there. All right, thank you for listening, and I'll see you soon. Goodbye.